Hi guys, this is the video for chapter 8, lesson 2. Okay, so this lesson is basically going to be a review over the Pythagorean theorem and then building on that some more. So I know you guys have learned the Pythagorean theorem in the past, and if you haven't, don't worry about it because that's what we're going to look at today. So the Pythagorean theorem is basically just an interesting phenomenon that we see related to the legs of a right triangle. So what we notice is that the hypotenuse of a right triangle is always the squared sum of the legs. So there's some cool graphics that you can find showing this, the reasoning behind this. And I've done this with you in 7th grade if you took me in pre-algebra. But basically what we see is that the legs squared, which A and B are the legs, will always equal the hypotenuse squared. So this equation, although is the one that we rolls off our tongue and we remember the most, a squared plus b squared equals c squared, remembering that really the idea behind it is the legs squared plus the legs squared equals the hypotenuse squared might be more important. So this equation right here, it's the same thing, but the information in here is more specific. So basically that's what we're going to do. We're going to identify what's our hypotenuse, what are our legs, and then plug that into our equation. So number one, x is our hypotenuse. We can also tell because it's across from the right angle. That's another way. It's the longest side and it's across from the right angle. So we know this one would be 3 squared plus 3 squared equals x squared. Plug that in our equation. 9 plus 9 equals 18. 18 equals x squared. To get rid of our square, we can square root. So 18 square rooted is our answer, and you can write that as a decimal as well, and I have to plug that in here. Which is 4.24. Okay. So if you want to write your answer as a decimal or a square root, that's fine with me. Number two, what we're missing is a leg, so we're going to write 9 squared plus x squared equals 15 squared. 9 squared is 81. X squared is unknown. 15 squared is 225. So now we're going to subtract 18 on both sides. X squared equals 144. To get rid of our squared, we can square root. X equals 12. Okay, I think the rest of these are no big deal, right? 3, 5, 6, same thing here. Now let's take a look at number 4. We've got some fractions. I think it's 4/9 and 5/9. So same thing, let's plug it into an equation. X squared plus 4/9 squared equals 5/9 squared. So when you are squaring a fraction, this square goes into the numerator and the denominator. So you're going to square the numerator and the denominator, which means I have 16 over 18. Sorry, 81, 16 over 81, and 25 over 81. So now you're going to work this out as a fraction, subtract on both sides. X squared equals 9 over 81. Now you square root, and when you square root a fraction, you square root the top and bottom. So 9 square rooted is 3. 81 square rooted is 9. So it's 3 over 9, or 1/3. That would be your answer. So go ahead and pause, work out the other 3 problems, see if you can get the right thing, and I will put the answers up here. Okay, let's check our answers. So number 3, x equals 60. Number 5 is the square root of 1,345, or 36.67. And number 6, x equals 25.75. All right. I want to teach you guys about something called the Pythagorean triples. So the Pythagorean triples are basically just three whole numbers that make up the sides of a right triangle, and they form the Pythagorean theorem without having decimals, okay? So one example that we see would be 3, 4, and 5, and you can tell that the longest length, it will always be the hypotenuse. So we can check these. This is an example where all the parts of my right triangle are whole numbers, and it fits into the Pythagorean theorem. So if I plug this in, 3 squared plus 4 squared equals 5 squared, then I have 9 plus 9 plus 16 equals 25. And so when I check this 25 equals 25. And so that works. So that works in my Pythagorean theorem. I'm going to make a little list of a few Pythagorean triples. Now, there's really nothing more to this than just remembering what they are and memorizing them. If you know and recognize these triples, it will largely help you when you look at right triangles where you can avoid having to solve using the Pythagorean theorem. So, for example, if I have a triangle that has a side that was 5 and 12, and you needed to find the hypotenuse, you knowing the triples could just say, oh, the hypotenuse is 13 because I know 5, 12, 13. That's all one set. And so these triples actually also go for the ratios of these triples as well. So if you multiply this by 2, then you have 6, 8, and 10. So this fits into a set of triples. Okay, if you triple this, you have 9, 12, and 15. So see how even the doubles or triples or quadruples of your triples will also have that same quality. So double 5, 12, and 13 would be 10, 24, and 26. That's a triple. Double these, right? You could double all of them. Then you'd have 16, 30, 34. You'd have 14, 48, and 50. And then you could, triple it, and you'd have another set. So you don't need to memorize these because you know that those are just factors of, or multiples, not factors. They're multiples of your original set of triples. So if you know what these are, that will get you pretty far. And I wanted to show you a song, and the reason why I like to show you this song is because what better way to remember some information than through song. And so I know that as you watch this, you might be like, oh, really? But it is nice. My goal for this song is to get it stuck in your head so you remember them. Okay, and I quite enjoy this song, actually. It's pretty fun.
Hey, this is the Triangle, man. I'm right here in Evergreen, Colorado. This is where I grew up. This is Bear Creek, just kind of down from my house. And right over here, one of my favorite fishing holes. There's a ton of trout right here behind this rock right over here. It's a great place. You get your fly rod, kind of bring it back, lay that fly right down there. You can catch a big lunker. But one day when I was out here fishing, I thought of a song for you guys in my geometry class. I thought I'd sing it for you. It goes like this, kind of a country number. 3, 4, 5, I caught a fish alive. 6, 8, 10, I threw it back again. 5, 12, 13 was the biggest fish I'd ever seen. 8, 15, 17, I decided to name it Scaling. 7, 24, and 25. Here we go. 3, 4, 4, 5, I caught a fish alive. 6 and 10, I threw it back in. 5, 12, 13 was the biggest fish I'd ever seen. 8, 15, 17, I decided to name it Scaling. 7, 24, and 25. Now you may say, Mr. Triangle Man, what is your crazy song about? Well, those just happen to be the Pythagorean triples. And those make up the sides of a right triangle. So if you can memorize my song, you can know your basic Pythagorean triples. Just one more time, just so you don't forget. 3, 4, 5, I caught a fish alive. 6 and 10, I threw it back in. 5, 12, 13 was the biggest fish I'd ever seen. 8, 15, 17, I decided to name it Scaling. You know, fish are kind of scaly. And scaling triangles don't have any sides the same. 7, 24, and 25.
Okay, let's take a look at some of these problems on the bottom of the study guide. So these 3 problems on the bottom basically say use the triples to find the variable. So if you think back at the song, it's like, what? 3, 4, 5, I caught a fish alive. 6, 8, 10, I threw it back again. 5, 12, 13, it was the biggest fish I'd ever seen. 8, 15, 17, I'm going to call it Scaling. Okay, and it keeps going. So, 8, 15, 17. So we remember from our song, that's a triple, 8, 15, 17. So see how you can use that to help you find the parts that are missing without even solving. Okay, now these numbers are too big, it looks like, to be one of our triples that we did in our song. Let's think if there are any factors. Let's see, any numbers that are divisible by both of them. So this one's divisible by 9, but I don't think 24 is. This one's divisible by 5, but I don't think 24 is either. So let me see. Maybe let's try dividing by 3. We'll just give that a try. So 45 divided by 3 is 15. 24 divided by 3 is 8. Oh, I've got 8, 15, 17. But this x isn't 17, right? If I had to divide everything by 3 to get the triple, then I have to reverse it and multiply it by 3 to get the triple. So 17 times 3 is 51. So that is the answer. Looking at number 9, 28 and 96. 28, 96, let's see. I think we could divide it by 4. So try dividing by 4. This would be 7. 96 divide by 4, plug that in, is 24. Oh, 7, 24, and 25. Okay, so there's 25. But is 25 your answer? No. We've got to do the opposite of dividing by 4 to get the number. So we're going to multiply by 4, and I think that would be 100. Okay, that's 100 there. All right, going down to the next part. Your Pythagorean theorem. Now, Pythagorean theorems are specific to right triangles. So you can only find the legs, the relationship of the legs and the hypotenuse and the missing parts if it's a right triangle. If, when you plug it into the Pythagorean theorem, your legs squared added is greater than the hypotenuse, then your triangle is acute. So we can actually tell the kind of triangle by the relationship of the legs and the hypotenuse. Okay, if the legs squared added is less than the hypotenuse squared, then your triangle is obtuse. So you can actually use the Pythagorean theorem and work backwards to find out what kind of triangle you have. Now, something that's interesting is if you see a triple, you don't even have to work it out. You know it is but you know it's going to be a right triangle. So this is a multiple of the triple, 3, 4, 5. It looks like everything here is multiplied by 10. So I don't even have to work this out because I know that's a triple. It's a right triangle. Okay. 2, 3, 2, 20, 30, and 40. Now, I don't know for sure what kind of triangle this is. So I'm going to see if when I square the legs and add them, if that's greater than or less than 40 squared. So 20 squared is 400, 30 squared is 900, 40 squared is 1600. So when I work this out, I add this, that's 1300. Well, that's less than 1600. So if your hypotenuse is greater than the legs squared, then your triangle is obtuse. So you might want to look back up here to double check what the relationship. Okay. So we could take a look at any of them to see if they are divisible by the same number and become a triple. So like number 3, if we wanted to check and see if it's a triple, we could say, okay, all these are numbers can be divided by 6. So this would be 3. 24 divided by 6 is 4. 30 divided by 6 is 5. Okay, I have a 3, 4, 5. So this is another right triangle. Okay, so you can pause and work this out. Of course, you can square them, turn this into the Pythagorean theorem, square it and see what the relationship is. So this would be, when I add them together, 181. Well, this is greater. So the legs are greater than the hypotenuse, and so the hypotenuse squared. So this is an acute triangle. Okay, pause it and see if you can find these. Why don't you do 7 and 9, or number 9? Work out number 9. So number 9, work that out. That would be a right triangle. Okay, that's all you're doing there. I think that's all I have for you guys.